On the morning of January 30th, 1607, calm weather covered the Bristol Channel. There was no storm and no sign of danger. Without warning, a wall of water raced inland. Witnesses described massive rolling hills of seawater moving across fields and villages with overwhelming force. Churches filled with water, farmland was destroyed, and thousands of acres vanished beneath salt water. Up to 2,000 people died in a matter of minutes. Early accounts describe a sudden surge arriving around 9 in the morning on a clear day. There were no storm conditions to explain the rapid onset. The timing did not match any predicted tidal peak. These details became central when researchers began re-examining the physical landscape for traces of what could cause an extreme marine inundation of this scale. Multiple sites around the Bristol Channel show signs of abrupt, high-energy erosion that align with the early 17th century. Salt marsh deposits were removed. Sand sheets were driven inland across muddy ground. Two coastal spurs that once projected into the estuary were cut back sharply. These changes indicate a force capable of stripping vegetation, reshaping cliffs, and pushing sediment far beyond the normal reach of tides or typical storms. Fieldwork documented transported boulders and freshly sculpted bedrock surfaces. Hydrodynamic calculations based on boulder weight and distance showed that wave heights of at least 4 meters were required in the outer channel and more than 6 meters in the inner estuary. Flow velocities needed to move these boulders ranged from 12 to 18 meters per second. Storm waves would need to exceed 16 meters to generate the same transport, a scale that does not match the sheltered nature of the Severn estuary or the calm conditions recorded that morning. An erosion interval at Dunraven Bay was narrowed to between 1590 and 1672. A boulder train at the site was deposited by a single high-energy event within that window, directly overlapping the date of the 1607 flood. The geomorphic signature matches the impact of a fast-moving wave capable of transporting heavy material, removing coastal surfaces, and driving water deep inland. The 1607 disaster remains one of the most violent coastal events in British history. The physical evidence and the eyewitness accounts point toward a sudden marine surge with enough power to reshape the shoreline and overwhelm entire communities in minutes.